In this video, we are going to learn how to use row operations to solve systems of equations. In the last video, we saw how we could take a system of equations and write the system of equations as an augmented matrix. And we saw that when we had the RREF matrix, we could read off what the solution to the system of equations is. So in this video, our goal is to figure out how to go from that augmented matrix to the RREF matrix. So we want to know what sort of math do we need to do to turn this matrix into this matrix. Again, we have two perfectly good methods for solving systems of equations, substitution and elimination. These methods become too cumbersome when we have more than two variables. What we're going to be doing is we're going to be using what's called row operations to manipulate the matrix so that we can turn it into an RREF matrix. Let's look at the first type of row operation. So our first type of row operation is just a row swap. So if we look at this initial matrix here and the matrix after we did the row operation, you can see that what was in row 1 now is in row 2, and what was in row 2 now is in row 1. So we are swapping row 1 and row 2. This is okay algebraically because what we're basically doing is we're just taking our equations and writing them in a different order. That doesn't change the solution. Our second type of row operation is one where we multiply a row by a number, or we could think of dividing a row by a number. Both of those are the same. This row operation asks us to multiply row 1 by 1/2. So if we were doing 1/2 row 1, what we're doing is we're taking the numbers in our row 1 and we're multiplying each of those by 1/2. So we're doing 1/2 times 2, we're doing 1/2 times 4, and we're doing 1/2 times -10. So we would end up with, whoops, not 2, we would end up with the number 1 to -5. And you can see that is what we have in our new row 1. Again, this is okay algebraically because this is equivalent to taking an equation like that and multiplying the equation by 1/2, or multiplying it by, or dividing all the terms by 2, and getting this new equation. Multiplying a number across both sides of an equation is perfectly legal. Our third type of row operation is slightly more complicated, and what we're doing with this one is we are multiplying a row by a number and adding it to another row. In our example here, we are taking -2 row 1, and we're going to add that to row 2. If we are multiplying -2 times row 1, there's my row 1, so -2 times 1 gives me -2, -2 times 4 gives me -8, -2 times 3 gives me -6, and I'm adding this to my row 2. Here's my row 2. Row 2 is 2, 1, -1. When I add those two rows together, I get 0, -7, -7, and this is what I have in my new row 2. Again, this is legal algebraically because this is basically the same thing that we did when we were using the elimination method. If I decided that I wanted to get rid of my x variables, I probably would have multiplied this first equation by -2 and got this equation. I would add it to my second equation, and my result would be this. 0x minus 7y equals -7. Notice that those are the same numbers that I have in my row 2, my new row 2 of my matrix. Let's see the process that we're going through using row operations to take an augmented matrix and turn it into the reduced row echelon form matrix. This process is called Gauss-Jordan row reduction, or sometimes it's called Gaussian elimination. What we're going to do is we're going to work column by column. We're going to start by looking at column 1, and we're going to try to make it look like this. And the way we're going to do that is first we're going to get the 1 that is right here, and then we're going to use that 1 to get the 0. Then once we get column 1 correct, we're going to move on to column 2. Those will be different numbers once you do column 1, and you're going to make column 2 look like 0 and 1 using the same process. First you get the 1, then you use the 1 to get the zeros. This process, this algorithm, this step-by-step method, the first time you see it is going to seem kind of complicated. But if you rewind and watch the video again and do maybe 1 or 2 more, you'll get the hang of it. It isn't that complicated, but the first time it's going to feel like there's a lot of things going on. Here's my example of my system of equations that I am trying to solve. And so the first thing we're going to do is write our augmented matrix. Since I have 2 equations, I'm going to have 2 rows. Since I have 2 variables and a right-hand side, that's going to give me 3 columns. So my matrix, my augmented matrix, is going to look like 1, 4, 3, and then 2, 1, negative 1. And my goal is to make this look like 1, 0, some number, 0, 1, some other number. Remember, we're going to start by trying to fix column 1, and we already have our first task completed because the first thing you want to do is to get that 1 in the right spot, and we already have that 1. So all we have to do is make this be a 0. So let's get that 0 in that second row, in the first column. So what we're going to do is we're going to ask ourselves, what number would I need to multiply by this 1 so that when I add it to this 2, I get 0? Well, I would need to multiply that 1 by negative 2 so it will cancel out the 2. The row operation that we're going to do is we're going to do negative 2 times row 1, because that's where this 1 is, plus row 2, and that's going to become my new row 2. So let's do this row operation. So negative 2 times row 1, that would give me negative 2 times 1 is negative 2, negative 2 times 4 is negative 8, negative 2 times 3 is negative 6. My row 2 is 2, 1, negative 1. When I add those together, I get 0, negative 7, negative 7, and my new matrix looks like, this is my new row 2, so I'm going to have 0, negative 7, negative 7. And even though I did this little operation with row 1 here, I'm not going to change my row 1. I just used my row 1. So this is going to stay at 1, 4, 3. Now notice that my column 1 looks like we want it to. Now what we're going to do is we're going to try to fix column 2. So what I want this to look like is that 0, 1. And the first thing we're going to do is make this be a 1. So in order to turn a negative 7 into a 1, we could divide by divide by negative 7, or multiply by negative 1/7. So we are going to do negative 1/7, row 2, put that in row 2. So negative 1/7, row 2, that looks like 0 times negative 1/7 is 0. Negative 7 times negative 1/7 is 1. Negative 7 times negative 1/7, also 1. So my new matrix looks like 1, 4, 3. Notice I didn't change row 1 at all. The only thing I was changing was row 2. My new row 2 is 0, 1, 1. So now our matrix, we have that row 0, 1, 1 right here, and we just had gotten this 1. Our next goal is to try to make this 4 be a 0. So I'm going to ask myself, what would I have to multiply this 1 by, this 1 here, so that when I add it to this 4, I get 0. Well, I would need to multiply by -4. So the row operation I'm going to need to do is -4 times row 2, because that's where I have my 1, add that to row 1, and put that new row in row 1. So let's do this. -4 row 2, that's going to look like 0, -4, -4. My row 1 is 1, 4, 3. When I add these together, I get 1, 0, -1. So my new matrix is 0, 1, 1. Notice that I didn't actually change row 2, and this is my new row 1, 1, 0, -1. Also, notice that I now have the RREF matrix. Because I have 1s along the diagonal, I have 0s everywhere else, and I can write my solution. My row 1 in equation form would be x equals -1, and row 2 in equation form would be y equals 1. So my solution is -1, 1. Try this one on your own. Pause the video and work it out, and then start the video again, and I will show you the step-by-step solution. Again, I would encourage you to do a couple of these, and know that it's a little complicated the first time, but you'll get the hang of it. I hope you found this video helpful.